Bryan Offut. I'm an investor at Index Ventures, where I invest in companies predominantly in artificial intelligence and software infrastructure. Started my career at Palantir and then worked at MemSQL as well. So come from a deep infrastructure background, and then studied computer science with a focus in AI in school. And so I've been a huge fan of kind of watching what the progress in machine learning and artificial intelligence has been like over the past decade or so. But I think the folks that are here to answer questions have a lot more context than myself. So I'll quickly introduce each of you. And if you could just say something briefly so that people can put a name to a face after I go through your name, that would be fantastic. So first off, we have Pradeep Javangula. Pradeep is the VP of Machine Learning at Workday. Prior to Workday, he was the co-founder of Tumri Inc., which was acquired by Collective, and then subsequently Collective was acquired by Adobe, where he was the VP of Personalization and Machine Learning. So thank you for being here, Pradeep.
Thank you, Brian.
Next, we have Ashish Bansal. Ashish is the Director of Recommendation at Twitch, and also has a long history in machine learning at organizations like Capital One, Twitter, and many others. So Ashish, if you could raise your hand real quick.
I'm trying to raise my hand and seeing how well the Zoom virtual background fades out my fingers. It's a little psychedelic.
There we go. You know, this whole year has been a little psychedelic, so it's just one more drop in the bucket, I think. And last up, but certainly not least, we have Vijay Narayanan. He's the Chief AI Officer at ServiceNow. Prior to ServiceNow, Vijay spent time at a variety of different organizations working in machine learning, including head of content at Pinterest, and over a decade of experience at a combination of Microsoft and Yahoo prior to that.
Hello, glad to be here. Look forward to the conversation.
Awesome. So those are kind of quick introductions on our panel, but I think to kick things off, it would be great if each of you could give a more in-depth introduction to yourself. So kind of going in the same order that we just went through there. Pradeep, would you mind kicking us off?
Sure. Well, nice to be here. Thank you. Vijay, I know each other from prior lives as well. So yeah, I've been at Workday for about a year, leading the machine learning and AI team, operating primarily as a sort of central organization, referred to often as a center of excellence, where there's a horizontal data platform that we built, and on top of that, multiple pods of folks interact with each of our application business units for the purposes of ideating and building applied machine learning and AI solutions across each of our applications, whether it be human capital management or workforce management and the ERP related to financials and management and so on. So yeah, so prior to that, as you pointed out, actually prior to that, I think you missed out one part of my back. Sorry about that. I'm so sorry about that. Prior to that, I was at an organization called Symphony AI, which is an incubator and investing sort of. It's not quite a VC. It's a blend between a venture capital firm, a private equity firm, and an incubator all rolled into one, for the intent of investing money in building B2B AI software companies. I was a chief AI officer and a partner there. And before that, I spent time at Adobe as leading the sort of the AI effort. And these days it's fashionable to give it a term. So at Adobe, it's called Sensei. Like at Salesforce, it's called Einstein, and at SAP, it's called Leonardo or whatever. So that's the equivalent term there. So yeah, spent lots of years in the Bay Area. Was a founder of a couple of companies, and one of them, as you pointed out, was acquired by Adobe eventually. But mostly spent my time in search. So since close to 1999. Up until now, for the most part, cut my teeth in natural language processing, web search, enterprise search, and yeah, it's been an interesting journey. Things have sort of clearly turned around. When you told people you were doing machine learning in 2001, 2002, it's like, what is that? So I guess it's on the lips of every single software engineer and developer and data scientist about right now. So thank you for inviting me. I appreciate the time. Yeah.
Awesome, awesome. Yeah, and you it's a nice prelude to the question that I'll be asking once we get through the introductions around the evolution of this stuff over time.
Yeah.
But I guess before that, we'll go to our resident psychedelic background haver. Ashish, would you mind giving a quick introduction?
Sure. I work in recommendation systems. Most of my work in machine learning has been on recommendation systems. I'll probably start chronologically. Started working on telecom stacks and moved around quite a bit. Did consulting and eventually did some work with the digital marketing. And I really enjoyed that field. And for the past 14 to 15 years, I've been focused on customer retention part of digital marketing, which is why I spend a lot of time building recommendation systems, customer loyalty. Did a bunch of startups, lived for many years in Toronto, and then moved to the Bay Area maybe 5 years ago or so. And specifically in the world of loyalty and customer management, I think the key, if I think of marketing in general, there is the acquisition side, which is all the bidding and ad platforms. And then there is the retention side, which is now that you've gotten this person onto your platform, how do you intend to keep them there? And stats show that it's cheaper to retain a customer than to acquire one. However, it's much harder in some ways. And the focus for recommendation systems, ability to manage large amounts of data, including sourcing data from different parties in helping with this, has been a bulk of my focus in the machine learning area.
Fantastic.
And I have to say, thank Bindu and you for having me here.
Awesome. And Vijay, mind rounding us out?
Yeah, absolutely. First, thank you, Bindu and Bryan, for inviting and having me here. Maybe a quick. So one of the things I don't want to belabor my full resume. It has a very good similarity to I think Pradeep's profile over the years. So I've been at ServiceNow for about 6 months now, where I've started an organization, Advanced Technology Group, really to bring machine learning data and machine learning based capabilities across the platform, products, and solutions for our customers. I spent a couple of years at Pinterest, where I was heading all of the sciences and the systems engineering for the core products of Pinterest. So anything other than advertising, including the home feed, personalization, recommendation systems at scale, the search stack, the full search stack, both the text search stack and the visual search stack, so image search stacks, the related content recommendations, computer vision technologies, the applied sciences labs group, shopping, and various initiatives, primarily building machine learning based products for Pinterest. Earlier, privileged to spend about 6 years at Microsoft on the Azure division, helping to birth the machine learning services and the cognitive services on Azure, including Azure Machine Learning, a lot of text, computer vision, and time series based cognitive service APIs that are today part of the Azure AI platform. Was at my Yahoo Labs for about 6 years, where again built the technologies around personalization of content, recommendations, segmentation, behavioral modeling, advertising applications, etc. 3 years at FICO, Fair Isaac, building enterprise AI products, leveraging machine learning. And before that, I was in academia. I was an astronomer, leveraging machine learning for some really exciting discoveries that we could drive, which really gave me the first thoughts about the potential of what data, AI, and systems coming together can do across a broad spectrum of human endeavors. So I'll probably stop there just in the interest of time. Really look forward to getting into the questions.
Awesome. Well, thank you all so much for being here and for sharing a bit of your background. It's pretty clear between the three of you, the breadth and length of experience that you have in machine learning is pretty impressive. And, given how quickly this field has evolved over time, you know, it's a pretty unique perspective to have been along for that journey throughout many, many years. And so given that the topic of this particular panel is production artificial intelligence, production machine learning, I thought it would be great to kick off with kind of two questions. The first one is, you know, what do you define as production machine learning? Because that's a very varied definition. And then two, how have you seen that change over the 20 plus years that you all have been at it?
Really, Bryan, do you want to go with the same batting order, or?
Yeah.
I still have people jump in. Whoever wants to kick it off can kick it off, and we'll keep it that way.
Go ahead, Vijay. You should start.
Okay. So when I joined ServiceNow, one of my first tasks was even to figure out, okay, what does this thing AI? Because I think for many people, it can range all the way from data insights and BI to some people on one end of the spectrum to Borg and cyborgs on the other end. And I think there is a broad spectrum in between. I at least try to define a box. Not sure if that's what the conventional AI or what academics or researchers define it, but to me, AI at the end of the day is still a software system that drives better, that A, learns from data, B, in order to drive better decisions, actions, and experiences, and C, improves over time. Within that box, I think there's a fairly large spectrum of things that you can do that are what I call as useful without being either too much on the bleeding edge and not being able to realize the value, or being very silly and trivial. So within that box is how I call as what I define as AI. So systems that learn from data to drive better decisions, actions, and experiences, and improve over time. Now, with that definition, I think there's a very, very large spectrum of use cases that you can apply this to. At the end of the day, production ML to me is a software system that continuously learns from data and improves whatever objectives, business objectives that you're trying to solve. Business or non-business objectives, could be whatever objectives that you're trying to improve for your specific application, whether it's recommendation or whether it's image diagnostics, a radiology application, or anything else. But as long as it's a system that's operationalized, that learns from data, improves those objectives, and improves over time, to me is production.
Yeah, I'll jump in. I concur completely with that definition. Actually, it's a very well-defined way of thinking about learn from data and attempt to predict or affect decision support in some way, and to be deployable in a production setting, right? You know, the historical software approach has been much more of a deterministic notion, right? You know, that given a certain set of parameters or conditions and so on, so there is a reasonably well-defined flow chart, if you will, of an algorithmic execution in order to produce a particular outcome. I think the challenges that are posed by the AI and ML environment is that they're inherently data dependent, right? In the sense that the oft-quoted sort of phrase of garbage in, garbage out absolutely holds true here. There's also this notion of, does there actually exist an implicit pattern in the data that one can discern from potentially historical batch analysis, right? And does that hold true for incoming data sets or incoming responses from users or from other things that are currently going on? So this poses an inherently different set of different ways of thinking about deploying something that potentially addresses the need for predictive intelligence or prescriptive intelligence, right? The way Vijay had described. Now, the challenges here are that things that you thought would actually hold true as you were exploring data or as you were trying to discern a pattern from them may not hold true once it's deployed into real life production. In which case, what do you do, right? You know, do you back off? Do you potentially come up with a different model or an algorithmic approach? These are what sort of cause significant levels of challenges, whether it be in marketing automation, whether it be in diagnostic analyses, or whether it be in industrial IoT, or whether it be in financial services. I think across the board, these challenges are different, which requires potentially different stack, different tools, different ways of thinking about it. Yeah.
I'll probably just add a couple of things because excellent points have been made by Pradeep and Vijay. Just 2 or 3 points that I'd like to make. For me, I use a classical definition of ML, which is Mitchell's definition, building software algorithms that improve with experience. And the way that is important for systems or things that we put in production, if you have one more user on your platform, if you had one more company, if you had one more interaction, does the experience of everybody else on the platform also improve? And if so, then it is very easy to build a data or an AI or an ML moat around your product. And I think it is also a test that I use when somebody says that their product has ML or AI in production, is to see if by having more people, does the experience become better? Does the product have better outcomes? And the results are mixed. Different people have different things for the reasons Vijay and Pradeep mentioned. I also want to make a quick distinction between ML and AI. It's a framing that I've been using, which is that ML usually makes predictions, but AI makes decisions. So as an example, just to illustrate that point, let's say we build a system that can look at X-rays and tell you whether your hand is broken or not. So let's say that the system gives you a prediction, 80% probability that the hand is broken. That is not enough because a course of action, a treatment has to be decided. Somebody has to decide whether I should give a hard cast or a soft cast or not. And that is the decision that lies on top of ML that makes AI, in my opinion. So from a question perspective, I also want to understand when I look at systems, whether they are ML systems or they are AI systems. And the key distinction for me is who's making the decision. In a recommendation system, it is an ML system because the system is making a prediction or a recommendation and the user is making the decision. And that might change by the focus area or the specific product that we use it on.
Yeah, makes a lot of sense. And as someone who has broken their hand and has 3 screws in one of them, I am glad that at least at the time there was a doctor making that decision, though I am hopeful that at some point in time that could be replaced. You know, kind of building off of a lot of the stuff that you all just mentioned, one of the things that I think is quite interesting about production ML is that it's the holy grail, it's the end game, right? But if you look at getting there, it's quite an arduous journey, right? And most organizations are very early in that journey, doing data engineering to get the data prepared and kind of doing all the required prerequisites to be able to do any machine learning. And that's only getting more difficult as the data landscape expands, right? It used to be that you had a data person or a group of data people, but now you have data analysts, data engineers, ML ops people, DevOps people. And so it becomes this really gnarly landscape to figure out how to organize. So my first question is kind of, you know, starting at phase 1, how do you think about organizing teams from a purely organizational perspective in order to kick off that journey and start moving towards doing some of this more production grade machine learning?
I'll start. As you rightly pointed out, and I think most of us are familiar with this, is that it is, if you look at the sequence of operations that need to happen, is first to be able to access data that exists either in an enterprise or in a consumer context. If you're a first party provider like a Pinterest or a Google, this is probably not as hard of a problem as opposed to in the enterprise context where you have data literally strewn about in multiple varieties in different formats across a wide variety of systems. So let's call that ingestion. Right? The processing of that data, whether it be for the purposes of extracting structure from that content or the data, regardless of the type of data, is a fair amount of cognitive services or vision or NLP techniques are utilized for the purposes of structuring that data. And the third process is to figure out what kind of an underlying pattern exists, what's referred to as learning from data. And the ability to learn from it would be through potentially the application of a wide variety of modeling algorithms or fairly rigorous approaches right now that have been popularized that exist in terms of knowing what kind of a problem it is. They are different in terms of whether it be a classification versus forecasting versus anomaly detection versus other kinds of approaches that are needed. And once it's determined, once that model has actually been determined, to figure out what the efficacy of that model is, at some level of an empirical evaluation of that model about how accurate is it, how precise is it, and and along with it in some verticals where there's a fair amount of transparency notions that are important as well. What's often referred to as responsible AI or explainability parts, which hopefully we'll get into a little bit later, are things that are important. And once you've determined that, attempting to deploy it, right? So this whole model of, hey, this is how the world ought to work, existed in silos, right? I mean, people were doing data ingestion, aggregation, and some level of processing within the data marts and the data warehouse world for a long time, right? And the techniques that are used to process this kind of data have dramatically improved. The algorithmic approaches, whether it be TensorFlow and the deep neural networks or reinforcement learning or NLP advancement and so on, have significantly improved. And I should pay a substantial level of attention to the amount of actual underlying systems improvements that we have seen, which even make this possible at all. Things like elastic compute, elastic storage, elastic everything, right? In a model that doesn't break the bank, is what actually allows it to happen, right? I mean, I think the ML revolution wouldn't happen without Moore's law, and it also wouldn't happen without sort of cloud service providers' business models, right? And on top of that, the proliferation of, say, sensors, for lack of a better term, where data is in fact getting collected from billions of devices. The convergence of all of these three makes this stuff happen. But the rest of the math and the algorithmic approaches, I don't know if they've changed that dramatically, even since the 60s world, right? I mean, neural networks have existed for a long time. Backprop probably didn't exist for too long, but still, it's like, the incremental advancements there have been good. But primarily, I think the biggest factor has been the systems world. So that's what we've seen. Back in the day when we were building web search, and as Vijay would attest to as well, we were building everything. Everything from, cloud-based file systems to clustered computing to, deployment methodologies. All of that stuff for web search had to be handcrafted, right? Inktomy was the company where I cut my teeth on this stuff, and I was fascinated with sort of the, building resiliency into a large cluster of nodes and allowing for your system to not fall over when a network controller dies or a disk corrupts is also a part of systems engineering. And I'd give a lot of kudos to Google for having done yeoman's work on this front. So hopefully that kind of addresses the kind of things that I think have changed over the last couple of decades.
I can probably weigh in. I've done some startups, some big companies. So if I were to think about how to structure an ML team, I think the experience varies quite a bit on the maturity of the organization and the amount of data that is available for the work there. Even if you have a lot of data, it doesn't mean that you are set up to do ML or AI effectively because it requires slightly different thinking. I like to call this machine thinking, just like machine learning. You have to move from a deterministic world into a probabilistic world. So you have to have slightly different skills in existing people. So especially your product managers and your project managers, how they should evaluate, they should prioritize, how they should estimate. Now, specifically for the brass tacks people, if you haven't done AI or ML projects before, whether you're a big firm or a small firm, I've been a big fan of a skunk works type approach, where you take a very narrow, specific problem that is determined to have value and start with that with a couple of people. You could either hire them, bring them in as contractors, or partner with a firm. I think the important thing is to take it in small steps and make sure that you're continuously delivering value. It is very easy, and I've seen a bunch of companies being a little disappointed in creating a large AI organization and not sure if they're actually delivering value. So I'm a big fan of a skunkworks type approach. Start small and then slowly evolve your processes to match your software engineering. You do need specialization, but I think specialization comes with scale. The scale of a Google or an Amazon or a Twitter is not the scale of an average corporation when it comes to AI deployments, probably, and maybe I'm wrong, but the point is that right size for the scale. You might have scale today, start small, grow it big into something that you can work with.
Yeah, if you may start from 3, what are some common pitfalls to avoid, in a sense that describes the why, and then I'll try to address the first 2 as a consequence of that. So yeah, at the end of the day, it's a technology, just a new technology. It is, but it is still software. So whenever you think about what can I do with AI, sometimes people say, hey, instead of saying what can AI do for me, think about what do you want to do and how AI can help you. In a sense, you having clear understanding of the problem you're trying to solve is going to be super, super critical. Many often I find, yeah, I used AI, it didn't work. Well, what are you trying to do in the first place? Right? Think about, replace the word AI with compiler. Suppose there is a good compiler out there, a new compiler out there. What will you do with it? Right? You can do a lot of things with a compiler, but it depends on what are you trying to achieve. Are you trying to achieve a faster code? Are you trying to achieve a more optimized memory footprint? Or are you trying to have it more tolerant of errors and warnings? Or are you trying to be very strict in your compilation? What are you trying to do? What are you trying to achieve? Are you trying to reduce the footprint of your compiled code? It's around that. So very often, the places where I've seen AI efforts go haywire is over-indexing on the modeling component of it at the beginning, without fully understanding what is the end-to-end solution you're trying to solve, and having a crisp notion of what is success with or without AI. So defining that, I think, is the most critical thing. The mental example I try to play in my head is, and that I talk to my teams is, what is the end-to-end system going to look like? What is the end-to-end solution going to look like? What is success for that end-to-end solution? And AI machine learning is like one component of this entire end-to-end solution. Do this dumb exercise, replace that AI system with a random number generator. Build that end-to-end solution first. So it's just spitting out some numbers, right? Maybe it's a prediction and just a random number generator that's giving you some predictions, right? An output of a random number generator is still some number between 0 and 1. You can take it as a prediction. Are you able to define the full end-to-end solution, measure your business metrics, the things that you care about, and then replace that component of that machine learning component, that random number generator, slowly start introducing more and more complexity on the machine learning, and see if the metrics you care about go north or not. So the notion of AI first is good in the sense that you define the solution, but I almost want to start with dumb AI first. Like, I really want to make sure, are you able to use very, very simple models? Replace with rules there. Don't care about how sophisticated your model is. Don't index too much on it. Are you able to define the full end-to-end solutions, measure the metrics, hydrate the data through it, set up the full end-to-end solutions? Because then you have set up this full pipeline that you can then quickly iterate in the inner loop of improving the quality of the models and see if we can improve the model metrics. This is also incredibly valuable because it forces a lot of conversations about what is a good outcome of that project. Right? Is 10% good enough? Is 90% good enough? I don't know. Depends on what problem you're trying to solve. Right? If you go to increase the RPS or the relevance in search, Google would kill for a 1% improvement in RPS. If you talk to somebody with whose churn is maybe just a simple other extreme example, somebody say some products churn is maybe 50% and you're saying, hey, I'm going to reduce it from 50% to 49%. Would they care about it? Why? Unless you can bring it to half, it doesn't materially move the needle for me. So it forces that good combination about from what is success, which typically the products and product teams can define. How do you build it and how do you engineer it and how do you measure it, which is where all the engineers and the data scientists and machine learning folks can come into play. So going back to my first point about, hey, the first question about what tips do you have on how to structure an ML team? In order to optimize for such thing, I typically find that it's good to have functional experts, also experts in data engineering, experts in machine learning, etc., product managers, etc., as different teams. But invariably in the context of a particular problem, really form that cross-functional team that holds accountability for the end-to-end metrics and define that end-to-end metrics upfront. So you don't want to have the situation where your machine learning engineer or data scientist comes in and say, the F1 score in my model on this benchmark data set I've measured is blah, blah, blah. And the product manager here saying, yeah, but it doesn't move any of the product metrics. Sometimes that's a big disconnect. So setting projects like this, setting solutions like this, where that joint virtual team consisting of all these people needed with functional expertise needed to deliver that solution, and making sure they are end-to-end accountable for the overall metrics, whatever that success metric is, right? And that varies differently from application to application, product to product, company to company. But I find typically that's been a better path to success.
Yeah, and you all three touched on, I think one of the things that the media has gotten kind of wrong about AI has really pushed, which is that it's this magic box. It's this silver bullet to solve all your problems. And so I think lots of times organizations go, oh, we'll solve it with AI. When all AI is an enabling technology, right? It's a way of solving that problem, of which there may be others. And so viewing it as an enabling technology, I think is important in structuring how you think about building it, right? You would never go, oh, okay, well, we're going to go in a vacuum and build this magic piece of software that solves this problem. You would do it in an iterative fashion, right? You try something, you get feedback, you iterate on it, and eventually you end up with a product that
That's
solves the problem.
Point, Brian. That's a great point, Brian. I think that's a big distinction between classical software and AI software. In classical software, let me take a very concrete example. Suppose you're trying to implement, say, encryption in some layer, right? Maybe in the database layer, transport layer, wherever. And your product doesn't have it. Well, go talk to your customers. The customers say, hey, I need this type of encryption, this strength of encryption in this layer. Well, it's a pretty clear requirement. You go off, build that thing in your product, test the hell out of it offline without including the customers, test it, go back to the customer and say, hey, now turn on this feature and you'll get encryption at that layer. Done. In AI, typically you have to start with that full end-to-end solution. You launch with some quality, but you have a clear notion of what is the North Star metric that you're trying to move. What are the North Star objectives that you're trying to move? And then set up a process where you can iterate very quickly. But having that end-to-end thing built at the beginning, where, as I said, literally stick in a random number generator so you know what this thing looks like without the AI, and then improve it iteratively. And at some point in time, you also realize, hey, the amount of effort I'm putting into getting that incremental increment is not worth it for the ultimate business objectives. At that point, you stop and say, okay, it's good enough for me, and that is success. So I think that launch, iterate is going to be a very important part of the process. So you say, what does the end-to-end process look like? Having a launch, measure, iterate quickly is going to be very much the process that you optimize for.
Just to finish off the point, Brian, one thing that I didn't address is sort of like, how do we structure it today, right? Within our organizations or in prior organizations that we worked at. The thing that has worked for the most part is this is, I'm referring specifically to the product development. I completely agree that the four constituencies of people, domain experts, product managers, data scientists / machine learning algorithmic folks, and systems folks, all have to be on the same page for it to represent any kind of success. And I have seen way too many of them fail when they're not on the same page, right? And often they're not in the same org. They are, in fact, virtual scrum teams, however you want to call them. From a core product development and the build organization, there is a horizontal data platform team that delivers on things related to hybrid cloud layers, data ingestion layers, and aspects related to technical ops and DevOps and other sorts of sort of like ways of making that happen, which provide a set of services to the layers above, on top of which we have an org that are called intelligence services teams that build everything from anomaly detection systems to OCR to NLP layers to, things that are essentially reusable things that have broader applicability across our application layers. On top of which are the folks that are interacting and interfacing directly with the application teams to build specific use cases or specific products and SKUs that drive to specific outcomes and KPIs that are measurable, that are driven to some level of customer satisfaction. So it's that 3-stack org is what we have.
Got it. Yeah, and you all touched on something in kind of different ways. Pradeep, you explicitly mentioned kind of explainability as an interesting area. I certainly agree for a variety of different reasons. And one of the things that makes AI fascinating is it's a technical problem, it's a product problem, it's a problem-solving situation, and it's very fascinating ethically, right? There's a lot of interesting things to explore there. And then Vijay and Ashish, you both talked about iteration, right? Ashish through kind of this skunkworks model, and Vijay through your kind of random number generator example. One of the things I find really interesting about the combination of iteration and explainability is, artificial intelligence and machine learning can be applied to solve a problem, which is like the metric that I'm trying to measure, but it also gives off a lot of exhaust, right? You learn a lot through that iteration process that's probably relevant to the business more broadly, that often gets lost because the practitioner goes, well, that wasn't accurate enough, so I know it's wrong, but I'll tweak things and move on with my life. I'm curious if you all have any thoughts on how you're thinking about that. Are there ways you can take the exhaust, so to speak, from production machine learning models and feed them back into the business in a more qualitative way rather than purely in a retraining type of way?
Well, I'll start. This is the answer is yes, right? It is that anything that you build for the most part needs to be sufficiently adaptive, right? Which means that your telemetry associated with what are you deploying, what exactly are the response rates, and if they didn't concur with what your potential prediction mechanisms are, why not? Are the areas of exploration. So you need actually a fairly robust way of understanding in as near real time as possible the collection of responses. This is especially true in advertising and marketing tech, like Ashish could probably attest to as well. I was also doing a bunch of recommender systems and automated personalization layers. The other aspect is also that in a sequence of operations that are involved about determining what is predictive intelligence, there's a variety of factors that come in that potentially are actually either truly predictive, like such as this attribute is truly predictive of this particular outcome, and if so, at what level of confidence, right? What does the interaction look like between these two different features or these two different variables, and what does it mean from a segmentation perspective? What does it mean from an explainability perspective, right? And in so doing, you're actually attempting to figure out some aspects of bias that might exist in prior data, and especially in domains like at Workday, where we're governed by a significant level of employment law. It's not a nice to have, it's an absolute requirement, right? Where if you are attempting to figure out sort of if you're delivering on a solution that says this candidate shall rank higher than that other candidate, why? And knowing why and whether that has been informed by protected classes or other variables is super, super, super critical, right? And same is true in financial services, credit decisions, substantial legal initiatives, and my prior jobs dealing with sort of the DoD is very big on this notion, and they would not allow things into production. So to the point of like, does the exhaust have substantial value? Yes. I wouldn't even call it exhaust. It's sort of like a natural outcome of the process that you are leveraging in order to build solutions. So the answer is yes, definitely true, definitely the case.
Yeah, the thing about machine learning systems that I find is literally it's a combination of two things, right? There is that of today, if I look at software development, especially with Mode 2 type companies where it's mostly DevOps, right? So you're building things, you're operating, you're looking at the quality of your services, you're looking at how it's performing, you're tweaking the software, deploying it. It's a pretty good CI/CD system. So if I getting that level of tight integration, it's almost like an ML ops where you build the models, you put it into production, you're continuously watching the performance and figuring out good notions about where is it performing well, where is it not performing well, is the data distribution changing, are there areas where it's systematically drifting, having great visibility into it. Just like today, if you're running any service, you look at your metrics, right? You have great alerting, monitoring, looking at your metrics, and if things go south, you quickly respond to it. I feel like we need to bring machine learning into that loop. Right? A lot of these things are being done reasonably well in software. And again, we have done this in software for 50, 60 years. So bringing some of those best practices and almost making ML ops. I think this goes back to one of your questions about, hey, what do data scientists do, right? Is a remit just training the models offline? No, right? It has to be about owning the metrics that matter in real time, including, yes, your training, but also operating the things and delivering value, because that iterative loop is super important to make sure you're continuously improving the system. To the third point I mentioned earlier about where these systems improve over time, that is very, very much part of what I feel is a good machine learning process.
I would probably say that there is an interesting aspect of a feedback loop in several machine learning systems. So I look at exhaust in a slightly different way because Pradeep and Vijay have already made some really good comments and points here. You're trying to make a prediction, and then that prediction, you're actually changing the reality in a way. What would happen if you didn't make that prediction? That counterfactual view is very challenging in this kind of world. And building systems, holdbacks, other things that are out of the loop from your ML that help you answer the counterfactual. What would happen if you did not make this prediction is important. And therein lies a little bit of a challenge, because on one hand, you're seeing that your metrics are going up because of this ML model, which is what you expected. That's why you put the model in production. And you hold out a portion of the people and give them some other treatment just to validate your counterfactual. That is one of the techniques. There are other techniques that are possible. How do you combine that back? How do you make sure that you can use that information to improve and better your system is an important part. I'll make a comment on the data scientist part of the ML ops. I think Vijay characterized it very well. The question, there are cases where and a data scientist can actually come up with a model that doesn't fit the latency budget. So by latency budget, what I mean is I have a very huge model that gives me amazing outputs, but it takes an hour to generate the outputs. Consequently, when I'm serving a web page or I'm serving a mobile app, when a user makes a request, I cannot say to the user, wait an hour and then I'm going to give you back a result. It is possible for the data scientist to say, hey, I did my job. I built a model and it performs to the specifications you asked from a output performance perspective, but it doesn't meet the non-functional requirements So that is a gap in the industry today, in the sense that who does things like compression model compression, quantization, making, dividing up the prediction so that you can do some computation offline and store it and do pre-computations and do some online. And in production use cases, I think there is a movement from data science to machine learning engineers who are more used to answering these types of questions. Not only are they adept at building a model, but they know how to make the practical trade-offs between, say, latency and the complexity and the expressive power of a model. So that's also something that we are seeing in my organizations, both Twitter and here at Twitch/Amazon. The scientists are fairly well aware of production considerations and work together on those types of problems.
Great. Yeah, I think one of the things that's interesting about this transition, you guys have touched on this in a variety of ways, is the software tooling doesn't work because the relationship between the engineer and the software has gone from the engineer telling it what to do to, in some ways, the model telling them, right? It's flipped the switch a little bit, which requires a different set of tooling. We've only got 2 minutes left here. So building on that and a question that we just got in the Q&A, quick, a lot of people here are thinking about how to deploy production machine learning. ML ops is obviously a huge part of that. You all have been through that journey numerous times. If you could give one piece of advice to the folks in the audience about things to look out for and things to keep in mind as you're productionizing machine learning, what would it be and why? And we'll do a rapid fire round so we can get done here right at noon. But Pradeep, you want to kick us off?
I'm sorry, what question? I was actually typing an answer to one of the questions that was on the Q&A. Sorry, could you repeat the question? Sorry.
For sure. If you could give one piece of advice to someone that's looking into productionizing machine learning to kind of avoid gotchas, what would it be?
Well, make sure that you have your well, first thing is you need to be able to track the progression of data from a lineage perspective and what the models are that resulted from it, and then to the extent that you've actually deployed them into a production scenario and a runtime inference scenario, be able to track them pretty effectively and understand what the lineage looks like. Oftentimes it is sort of, something is deployed and forgotten and it's like all hell breaks loose and then you retrench and so on. So this requires a fair amount of engineering and pipelines and ways of coordinating. So that's what I would pay actually a bunch of attention to. And many traditional sort of like enterprise software systems that bring in aspects of AI and ML into their layers are not truly conversant with this stuff, and it requires some level of training. So hopefully that answers the question. Yeah, go ahead. I know we're kind of short on time.
Yeah, Vijay, quick take.
Yes, build the end-to-end solution, instrument, track your metrics, start with a random number generator for your machine learning component, iterate from there.
And Ashish, last but not least.
My advice is going to be very similar to Vijay's. I'm just going to phrase it differently and say that in many software systems, you have a fallback and graceful degradation. People don't pay enough attention to ML systems fallback. As an example, if you have a recommendation system that's recommending news articles, the fallback could be popular articles, which means that your system doesn't work or what it doesn't do. Similar to Vijay's idea of a random number generator, to me, the popular news articles is my random number generator, which is very easy to compute and provides a good fallback and also a baseline that your machine learning model should exceed.
Awesome. Well, thank all three of you so much. There's a lot of learning in that 45-minute long conversation, and we're 1 minute over, but got there pretty close. So thanks so much for joining us, and thanks to Bindu, Abacus, and AI Camp for having us all here. It was a fun chat.
Thank you.
Thank you.
all of you guys. Very, very much appreciated. I really actually learned quite a bit, especially around MLOps and productionization. Thank you. Okay, just to kind of finish off the summit, Bill is going to do the last raffle for the AirPods Pro, and thanks to everyone for joining us, and some of you for sticking around, I think, for the last